Hi everyone, I'm here with another video. Although it's been a very long time that I have uploaded a video, I'm extremely sorry for that. I couldn't get enough time and I was tied up with a lot of work in the past few months. Being said that, I'm here with something interesting today and which may not be directly related to SAP ECC applications of SD and MM, but yes, it is one of the most talked about topics these days. Well, I'm going to talk about Internet of Things as you see on my screen, which is also called as IoT. So most of the people might be speaking about this particular topic every now and then, and you might have even heard about it. But we might, some of you might not be clear of what exactly IoT is. So the intention of this video is to tell you what IoT is, how SAP is venturing into IoT services, and how is the ECC or the S/4HANA system that SAP is offering related with the Internet of Things services that SAP offers or is offering these days. So apart from that, I'll also be demonstrating a prototype that I've built using SAP's Internet of Things services and show you how the architecture of SAP Internet of Things services works. So this is going to be an interesting session for sure, and I suggest you to watch till the end to get detailed insights of what it is about. Okay, let's move on to the sheet which will have the details. So as you can see on my screen, the first image that you see over here, this image gives you an overview of what Internet of Things is. So it is also popularly known as IoT, which is the short form of Internet of Things. Well, what exactly is Internet of Things? Internet of Things is nothing but I'll explain it in this way. So until now, what was happening is that we as humans invented the internet or the web, and we ourselves started uploading data on the internet, which could be used by some other human being or a person who is in need of that particular data across the globe. So basically, if that person has that access to the data that you have uploaded, he'll be able to see the data and he'll be able to add comments on it and tell his views on how the topic is and what his views are about that particular topic. Basically, you're sharing information across the globe using the internet from one person to another person. So now, what is Internet of Things? Until now, there was human-to-human communication mostly across the web, but with the advent of Internet of Things, we'll be having the devices or the things. So the things, the terminology things in the concept of Internet of Things represents any object, whether it is living or non-living. Uh, that object which has a ability to send useful information about its performance on the internet so that it could be accessed by authorized individuals or authorized computers to generate sensible data out of whatever data has been gathered from these things. So a thing can be an animal, a pet that you have at your home, or the cows that you're rearing, fish that you have in the sea. It can be any business related entity like a factory or a plant, or the machines that are there in the factory, the robotics that you have in the factory to automate assembly lines. You can have a thing which can also be a car which is manufactured by a particular business firm or an OEM. So a thing can be anything. Even it can be a thing that resides that you see in your home, basically an iron, a lamp, a night lamp, a washing machine, or a fan, or a vending machine. So connecting these things to the internet, the concept of connecting all these things that you see on my screen to the internet is called as the concept of Internet of Things. Once these devices are connected to the internet, we are capable. of having a look at the real-time data of what these devices are feeding on the internet or supplying the data to the internet. So once we have the real-time data of these devices, we are in a position to, analyze the data that we have received and get interesting insights out of this. So in a business scenario, let's say a washing machine is manufactured by one of SAP's customers, let's say, and this customer uses ERP or S/4HANA in the backend to track all the sales. Secondly, they can have an Internet of Things application which would track how the device is performing when it is at the customer's location. Let's say a customer has bought this particular product and he is using it daily. So the daily usage statistics of that particular device would be received by the manufacturer, and the manufacturer would be in a position to analyze how the device is performing, and he could even know whenever a device might stop working. So he can know in advance there might be an issue with the device and the device might stop working, and he could call the customer and tell him in advance that I'm scheduling a field service technician to, repair your device before it gets damaged. So this way, the manufacturer is well in advance aware of about what is happening to the product he has sold to his customer, in turn enriching or having higher customer satisfaction and customer loyalty. So this is one of the example of what IoT is, which can be used in general purpose business framework, or you can even use it in your home to monitor a lot of stuff like your electric night lamp. You can monitor your vending machine. You can monitor the fan in your house from the internet basically. So it's not only getting the data out of the devices and analyzing it, but yeah, Internet of Things provides you the capability of controlling these devices from any part of the world as well. So basically, I can switch on and off the light in my bedroom from any corner of the world when it is connected to the internet. So that is the power of Internet of Things. Then the second question over here you see is, why is Internet of Things popular these days? Why not earlier? Or because the internet is there since 1990s, and why couldn't it be, you know, uh, why couldn't Internet of Things, why wasn't Internet of Things used in the past as well? Because it's almost 10 years or 20 years from 1990, and we are hearing this terminology these days in the year 2017 and 18. Why it is being popular, so popular now? First and foremost thing is almost half of the world, as they say, would be connected to the internet by 2018. So the connectivity, the number of people connected to the internet in the 90s was very less as compared to what it is now. So this indicates one thing: the wireless internet is spreading very fast, and every other person in this world needs to have an internet connectivity or is having an internet connectivity. Basically, even the remotest part in the world, you'll have internet connectivity over there. So these days, because of the easy availability of internet, we are able to connect any particular thing which might be in the remotest part of the world. We can connect that product to the internet. Earlier, this was not a feasibility, and only a few handful of people had that access to the internet. And since it was costlier, gradually it started becoming cheaper and started spreading across the globe. So that is one of the reason, which is people connected to the internet. Well, the second reason, or the second parameter, which is very which is one of the important part of the Internet of Things architecture, is the sensors and embedded devices. and these are also called as the microcontroller units, MCUs. So what? So now we spoke about the internet. Now the data of all these things that you see on my screen or in this picture, the data collected from these things uh, is being sent to the internet using the internet or the wireless internet services that are available in every nook and corner of the world. But the primary hardware, as you may say, that is required to gather the data out of these devices. So these people are like these things are not smart. They are not able to send the data on its own. It's impossible to send the data from these non-living things or living things on its own. Just having the internet connection and these devices will not suffice. Well, we need the sensors and embedded devices which should be hooked onto these devices. So sensors and embedded devices are pretty small, and the price of each sensor is going down day by day, and sensors are getting cheaper. Since every device that we want to track or monitor needs to have a sensor, and there needs to be an internet connectivity for over there for the sensor and embedded device to connect to the internet so that they could push on certain important parameters that have been tracked for this device onto the internet. So sensors is going to be an important sensors and embedded devices or microcontroller units are going to be an important uh, part of the internet of things architecture. Hence every single device that you want to track needs to have a sensor, a microcontroller, and an internet connection available in that particular area where the device is located. If one of this is missing, you won't be able to get the data out of your device or product or the thing, as they call it. So basically you need these two parameters, and since these two parameters are nowadays available in abundant and are pretty cheap, hence in the year 2017 and 18 we see or we expect the Internet of Things concept to be utilized in every other product or every other product that we see these days. So basically the concept of Internet of Things would be applied in every possible way because it is getting cheap and the internet is available in every nook and corner of the world. So these are the parameters that have led to Internet of Things concept flourish these days, and hence it was not popular in the earlier days of the web. Well, now since we have seen a generic idea of what Internet of Things is, let's move on to how SAP is helping us do that. So there are a lot many companies who offer Internet of Things services. So by Internet of Things services, we mean they'll offer a cloud platform. This cloud platform will provide you a cloud database to store the data that has been received from your device. They'll provide you a development interface. So what is this development interface? Application development interface, you may call it, to be precise. Application development interface. So now what is application development interface? So whatever data you're getting from your device, this is stored on the cloud database. So there will be a database table wherein all your records that are received from your sensors are being stored. So just storing the sensor data is not enough. You have to go ahead, process further that data and get insights out of that data. Insights basically, you might have a pie chart which could give you a decision making ability of so the pie charts will be based on the data that has been received from your sensors, or a graph which could indicate how the performance of your product is. Or secondly, let's say if it's a refrigerator, you need to track the temperature. So in that case, the temperature data on the graph would help you take appropriate decisions. Like if say the temperature goes beyond 15 degrees Celsius, or 20 degrees Celsius, you may say that the device is not performing well and it needs repair. Or there is some malfunction in the device and someone has to go there and take care of the device before it completely stops working. So, so the database will store the data and then the application development interface will help you build apps. Sorry, will help you build apps, or these are the front-end apps which could be used by the users or the company or the manufacturer of that particular device to get or to understand how the device is performing at the customer's end. So irrespective of where the device is located, the user or the owner of that product who has manufactured that product can track and see how the device is performing and is the customer satisfied with the product by checking the usage and w- let's say what all important parameters they have on the device. Those parameters could be checked. Let's say in a refrigerator, as I told you before, it will track the temperature and see how the temperature is maintained throughout the day and whether the temperature is going beyond certain threshold. And if it's going beyond a certain threshold, it will require some service. So this is how most most of the companies that offer Internet of Things services work, or they offer the services in this way. So they'll offer you the cloud database, basically a platform which will hold all these things together. Application development interface. They can even build you apps and give you an app directly which you can use or consume. Third thing is device management. So basically, you can have n number of devices to track your products. So let's say you have thousands of products which have been sold to thousands of customers. So in that case, every device is going to every product that you have sold to a customer is going to have one tracker fitted on it or a sensor placed on it. So that sensor is going to give you data for that particular device. So that particular thing of managing thousands of devices is being done by the device management uh, cockpit. So here in the device management cockpit, you can manage thousands of devices which have been installed on thousand different customers. So whenever one device sends the data, you will have each device that has been installed at a customer's location will have a different name, and you'll come to know that from which customer are we receiving the data at the moment, and that way you can track n number of customers and accordingly identify which customer needs service and accordingly to call him and get his approval to service the product so that before it fails. So these set of services are being provided as Internet of Things services by a lot of companies, like Amazon has AWS, Microsoft has Azure. Similarly, SAP has its own Internet of Things services. So now let's see how that particular setup is done using SAP Internet of Things services. So SAP Internet of Things services is offered by SAP's HANA Cloud platform. Don't mess up HANA Cloud platform with S4 HANA. S4 HANA is the business suite or the advanced version of ECC that we are having, which will have all the standard modules that we had earlier, like SDM and PP. But HANA Cloud platform is nothing but a, a cloud service wherein you can develop apps, you can have your own database created, and manage your n number of Internet of Things devices. So I'm just telling you an example of how HANA Cloud Platform could be used to manage Internet of Things. Okay, so apart from Internet of Things, SAP also has other digital innovation system that it has to offer all these customers. So if you have a HANA Cloud Platform account, you will be accessing all the latest digital innovation systems like machine learning, blockchain, and analytics. So whatever things are trending these days would be under this header of SAP's Leonardo technology offerings. So one of them is Internet of Things, and which is what we are going to discuss today. And this architecture that you see over here is specifically for IoT. So I'll have a small microcontroller. This microcontroller will have input-output pins, and these pins will have a sensor tagged to it. So a sensor is going to sense the readings out of that particular product which is at the customer's location, and it is going to connect to the local internet connectivity connection that is available, and then send the data onto the SAP's HANA Cloud platform. On the HANA Cloud platform, you will have the cloud database where the data would be stored. Let's take an example of recording the temperature and humidity in my living room. So I'll place this microcontroller in my living room, which will sense the temperature as well as humidity, connect it to my local home Wi-Fi, and then post certain readings that it has got out of the sensors onto the HANA Cloud Platform database. So once the data is available in the database, immediately the application that we have created to consume the data from this particular device, which is located in my living room, that device will pick up the latest data that is available and show you the updated data of what is happening in your living room. So what exactly is the temperature, what exactly is the humidity and the photosensitivity, whether the room is dark, light, or does it need light, and all these things. So these three parameters would be available using your phone. I can see it from any part of the world. So I can always track what is happening in my living room, basically based on these three parameters that I have. So how hot it is, what is the weather in my room, or what is the temperature inside my room, whether it is hot or cold or moderate, and so on and so forth. How much humidity it has, and so on and so forth. So all these things could be done using this architecture that you see over here. So the interesting part of this session or this video is that I'm going to demonstrate a prototype that I have built using this architecture of SAP HANA Cloud Platform. Now I've shown you a link over here. What this link does is that it is going to communicate with the backend applications of SAP S/4HANA or ECC. Basically, the applications like SD, logistics, and all those things. So mostly it would be useful in logistics scenarios wherein you need to track your shipments, where the shipment is, at what point is it. Especially in pharmaceutical companies, you need to track the temperature of the shipment as well, because if the temperature of the particular truck goes beyond a certain level, the drugs which are being transported across using in the shipment might get damaged and spoiled, and which are no further um, consumed, which should not be consumed because it might lead to some other circumstances. Hence, such stringent tracking is also can be possible using SAP's Internet of Things services. So this way you can connect your backend SAP S/4HANA with HANA Cloud Platform and track and trigger certain actions into your SAP applications, like create a written delivery or do a GR or whatever actions you want to do. So basically this app is going to trigger all the actions that in the backend of S/4HANA based on the sensing data that we have received from our device. So these actions will in the end go ahead and create certain documents in S/4HANA or SAP ECC. This way, bridging a gap between the application that we have built up on the HANA Cloud platform and the SAP S/4HANA services. Not the services, but S/4HANA Business Suite, wherein we can have all our applications running or real-time business running. All right, so this way we'll get the real-time data and we can sync it back with S/4HANA based on the actions that we want to perform. Okay, so let me quickly go ahead to the next thing. But before we go to the next thing, let me tell you that these controllers that you see over here are capable of connecting to the local Wi-Fi if you provide the local Wi-Fi ID and password, and they are also capable of getting out the correct data out of the sensors. So basically, simply attaching the sensor to this controller and placing it near your home Wi-Fi is not going to serve the purpose. These controllers require certain code which needs to be fed into it so that it will perform the actions that have been mentioned in the code. So basically, only after you code it and activate it, it is going to get this correct data out of the sensors and then connect it to the internet and then post the data onto the HANA Cloud database. So you'll have to code this device and also develop an app by coding so that it reads the data out of the database and shows you graphs or insights, whatever it is. So that way, you will need uh, inputs in that area, like coding the coding the microcontroller usually uses CPP or C languages, and this would require in SAP HANA Cloud Platform, you can code or get your app done using HTML5 or UI5 languages. So over here, if you see, I'm going to show you the end results of what I have done. So this is the code that has been fed into my microcontroller, and this is the output that has been generated out of my microcontroller device. I am seeing this output on my computer. So this whatever output I'm getting is being fed to the cloud platform database, and that database is being accessed by this front-end app that I have on my mobile phone. So this is a mobile phone screenshot, and I could get the readings of photosensitivity, humidity, and temperature. So this is what I'm going to show, and I'm going to vary the temperature of my device and see how the fluctuations happen over here in the demonstration that is to follow. So let's start with the demonstration.
Microcontroller device. This is the temperature sensor and humidity sensor. If you want to see this, I'll show this to you. This is switched on if you see. And this one over here is a light dependent resistor which will uh, increase the resistivity based upon the intensity of light. So I have connected these devices 1 and 2 to my microcontroller board, and this microcontroller board is powered using a 5-volt power source. Once this is powered, this is too small. If you see, it's not even my fingers thumb's length. It is so small, and these are the wires that I have connected across, which will give connection to my to power up my humidity sensor as well as the light dependent sensor. And these are just the wires that have been connected from these input output pins. If you see this one, go to this side, left and right side, these are the input and output pins, and this is a module which will help this microcontroller, this whole unit, to communicate with my home's Wi-Fi. So if you see here, I have this device, I have the second sensor, first sensor, second sensor, which will sense, the first sensor will sense temperature and humidity, the second sensor will sense the light in my room basically. So if I cover this, it'll show less light. If I open this, it'll have more light.
Now you can see my application that is running on HANA Cloud Platform, and this application could be accessed online for the users who have the authorization to this application. And simultaneously I have my device running, and these are the real-time sensitivity sorry, as of now you see I have n number of devices. As I told you, if there are 1,000 customers, there'll be 1,000 different devices, but I have only 3 devices set up at the moment, and I'll select the middle one, which is currently I am tracking, which is the device which I am currently tracking. And these devices will have as I told you, 3 measures. One is temperature, humidity, which are selected at the moment, and the third measure is photosensitivity. So for now, the temperature, it shows that in my living room it is around a little less than 60, while the temperature is a little less than 30, which might be up to 28, 27. So that's the correct temperature in my room. Now let's see the photosensitivity. I'm showing, you can have a look at the small window pane that shows the device, actual device. So the photosensitivity shows as 300 based on the existing light conditions. If you see the LDR in the small window, it is now having some light, and it is showing a reading of 300 and a consistent reading of 300. Now, how do you know that it is giving me the real-time readings? If you see, the map is getting refreshed and we are getting a live feed of what is happening. So every second the readings are being taken and pushed onto the database, and that database is being accessed by this application that you see on my screen. So these seconds, if you see, it is 1927 now over here, then after some time it will get refreshed, and this 1927 will move towards the left hand side. And if you see the date, it's the date on which I am recording the readings. So 1927 just moved a bit left, and you'll see milliseconds, 15 milliseconds, 30 milliseconds after 1927. Oh, sorry, 15 seconds. So now what I'll do is that I'll cover the light dependent resistor. So if you see this resistor over here, I'm going to cover it with my finger. So what it will do is that it should dip down the sensitivity. So if you're seeing my the main screen graph UEFI app, the sensitivity is dropping gradually. So let's wait for another reading. Okay, it's gone to zero almost. And now I'll take it up off. My finger has been taken off and it should shoot up now gradually. So the database gets updated. As and when the database gets updated, you'll have the next reading being taken up by the application, and now it has gone up to the normal level. So gradually it will go a little above 300. If you see 300 over here, and the latest reading is 1928 30 seconds. So yes, it has gone above 300. So this was a quick demonstration of what I did to completely understand how SAP's IoT services work. So now let's go ahead and uh, check what all things I did in order to achieve the end results that I'm showing you right away. So I'll be covering that part in the next video because this video is getting too longer. Hence, I would like to have a separate video to show you what all things I did. If you're interested in this, please let me know and add your comments below so that I could, spend some time and bring you guys up with a video which will demonstrate all the technicalities that I did in the backend to have this whole setup running. So once you run the whole end-to-end cycle, you'll get an idea of what is happening. Thank you guys. Bye bye. Like and subscribe.